Along with the agree and disagree statements that we had for our bell ringer, while we're taking notes, I want you to be thinking about the objectives for the day. So you can see that by the end of class, I'm going to expect you to be able to do a couple of things. One, describe the position of an object and be able to tell me what 3 things should be included in your description of the position. Okay? You're going to need to be able to explain to me what a reference point or a reference direction is and why it's necessary. And then finally, you're going to need to be able to tell me the difference between distance and displacement. Okay? So if we get to the end of class and you're like, I can't do that thing, I can't do bullet point number 2, maybe come talk to me. You might have missed something. Okay? All right. To start off, we are going to do a little launch lab that's on page 9 of your textbook. Not everybody needs to get a textbook. You're going to do this with a partner. So choose your partner, and one of you go get your book and turn to page 9. All right, you can follow along as I go through the instructions, okay? But essentially what you're going to do is practice giving the position of an object, okay? In order to do that, you're going to take a blank sheet of paper and you're going to label the top of it north, the bottom of it south, and then west and east on there. And then you're going to place that paper on the ground near where you are now with north pointing that way, okay? Then you're going to pick a spot in the room to move to. You can either move to the board from your spot, you can move to my TV, where my TV will be from your spot, or you can move to this back bench from your spot. And the idea is that one person will walk from where you started to that location that you've selected, and the other person will keep track of what direction they're moving in and how many steps they're taking, okay? You don't need to write this down like on your notes or anything, but if you could keep track of it in your brain so that when I ask people to share out, you have it there mentally ready, okay? So one person is keeping track, the other person is moving. Obviously, the moving person should maybe say their step count out loud so that the person keeping track can tell, okay? So from wherever your paper is to either the whiteboard, where my TV is, or the back bench, you pick where you're going, okay? So let's have a couple groups share out. Where did you go and how long did it take you? Anybody? Somebody who went to the TV. Sure.
10 steps south.
10 steps south. Did anybody else go to the TV? How far did you move?
5 steps.
5 steps?
Yep.
And still south, because it looks like that's the direction we'd be going. Okay? Yeah. Okay. So, how did your instructions compare to those written by other groups? Were they the same? No. How did your description of your movement depend on where you started? Yeah, it could have depended on how big of steps you took, right? Some people have longer legs. Okay? But definitely, if you were further north in the room for your starting position, you were going to walk more steps than if you were further south, or depending on which object you moved to. Okay? So the idea for this lab is that your paper that you started on is what we would call a reference point. Okay? A reference point is the starting point you use to describe the position. Okay? And a reference point is very important because if you don't have a reference point to compare to, it's going to be confusing to give someone directions to an object. Okay? It gives context to your motion. The house is north of what? To the left of what? Okay? And if you change the reference point, the position of the object changes based on your description. Okay? So recently my dog escaped from our backyard. He got off his leash and was running amok about town. And one of my neighbors called me and they said, hey, I saw Beans, he's headed north. And I said, great. North of what? Because I needed a reference point, okay? North of Main Street gives me a whole half of town that I've got to check. North of my house, which is on the very northern edge of town, is significantly different, which turned out to be where he was. He was in someone's alfalfa field. So he had taken off north of our house and was just gallivanting around having a great time. But I needed a reference point, okay? Because without a reference point, the direction north really doesn't do me a lot of good, okay? So you can see why a reference point is one key thing you must have to tell someone the position of an object. Okay, you should always start with a reference point. House might be north of a pond, but southeast of a windmill that's on a property. So you can see how changing which object you're using as your reference point changes the position of that object. What we're going to do next is we're going to do a little mini lab to approach the next idea, okay? This mini lab is in your books, but I have the instructions here so you don't have to flip to it, okay? Basically, what you're going to do is you're going to collect a meter stick, okay? And I'm going to give you a sticky note, and you're going to put your sticky note at the 50 centimeter mark, very middle of your meter stick. That's going to be your reference point for this lab, okay? Then you're going to take a small object, so you could use a pen, you could use your finger, and you're going to put it on this meter stick where I tell you to, which in this case is at the 40 centimeter mark, right here. Okay? This is 10 centimeters away from the 50, but as you will notice now, because the 50 is in the middle of the meter stick, there is also another location that's 10 centimeters away from the 50, right? So I need not only a distance, but I need a direction. And since this is not like a north, south, east, west situation, we're going to use positive and negative as our directions. So when you are moving to a number that is less than 50, we're going to call that the negative direction. When you're moving to one that is greater than 50, we're going to call that the positive direction. Okay? So then we would move this here in the negative direction, and we would say we have moved a distance of 10 centimeters negative. And we're going to fill that out on our chart, which looks like this, which is actually already filled out for you. You can see the first line there, right? 40 on the 40 is 10 centimeters to the negative. So what you're going to do is you're going to attempt to fill out the rest of this chart using your object and your meter stick. Okay, so if it tells you to move 40 centimeters, but in the positive direction, you're going to end up somewhere over here, right? And whatever centimeter mark you end up at is what you will put in that blank box for position. If they give you the position and the direction, but they don't give you the distance moved, you have to figure out the distance you moved. Okay? All right. So grab a partner, grab a meter stick. I'll have sticky notes up here for you. So, to begin with, if I start at the 50 and I travel 40 centimeters in the positive direction, where do I end up? 90. I end up at the 90 centimeter mark, right? What if I start at the 50 and I only travel 15?
65.
I end at the 65. If I end at the 75 mark and I know I started at the 50 and I was moving in the positive direction, how far did I move? 25 centimeters. And then if I end up at the 30, what direction did I move in? I moved negative. And how far? 20 centimeters. Okay, so that's what we were looking for here. Hopefully that's what you got. Should look something like this after you filled it out. Okay. And what we just learned and discovered is the other two things you have to have for telling someone the position of an object. First, we said you need a reference point, Now we know you also need a reference direction, and you also must have a distance associated with it. Okay? The reference direction helps you complete the lab because you know which direction you're moving from the 50. It's also important to note that this was one-dimensional movement. We were moving back and forth on a straight line. But how often in your everyday lives do you just walk on one straight continuous line all day?
Not very long.
Not very often, right? We often turn corners and move because we do not live in a one-dimensional world. So if you're going to give directions in 2 dimensions, you're going to need still a reference point, but you're probably going to need more than one distance and more than one direction. Okay? But you will always need a reference point, a reference direction, and a distance. So that is our first objective. Describe position, reference point, reference direction, and distance. It's actually our first 2 because now we understand why reference points and directions are important. So, okay. Which means, greeted by sighs in the room, we're not that far from the end of the notes is what that means. We've only got one objective left, okay? Motion is the process of changing positions. To tell that motion is happening, you need a reference point. So, not only do you need a reference point to describe a position, you also have to have a reference point in order to know that something is moving. Okay? So the example I like to give is if you are looking up at the clear blue sky, there are no clouds and you cannot see any of the surrounding ground. You can only see sky. It is very difficult to tell if an airplane in that sky is moving. You need either clouds or buildings or trees or landforms around you to tell that that plane is actually moving across the sky. Okay? So in order to tell that motion is happening, we have to have a reference point to go with it.
I'd hope if I looked further.
I would hope so, right? Logically, we know the plane must be moving if it is in the air, because if it was not moving, it would be falling out of the air. So, okay. There are 2 ways of describing motion. We've talked a little bit about the first one already, but let's go ahead and give you the full definition for it, which is distance is the length of the path that an object moves along. Okay, so if this is like 5 meters, when I walk from one edge of my desk to the other, my distance is 5 meters because I have moved that far. Okay. And this is the one you are probably most familiar with because when people ask you for distance, this is what they're talking about. In science, however, we're going to have one other term, which is displacement. Displacement is the difference between the initial position and the final position of an object. So to illustrate this, I will do a little more walking. If I walk from right here to the other end of my bench, but then I just walk back to this corner of my bench, I've traveled a decent distance, right? But I'm not very far away from where I began, which means that while my distance might be large, my displacement is actually quite small because displacement is the shortest distance between where you started and where you ended. Okay. If you walk a straight line, then your distance and your displacement will be the same. But if you move back along that line, or if you move off in another direction, they're going to be different. The example that I like to give comes with a little drawing. If you're not done writing, don't worry, I will be coming back to that screen, okay? So I like to draw this little image with 2 little houses on it. And little Bobby lives in house A, and he wants to go to house B because that's where his best friend lives. But the problem is that there is a river between their houses. And the bridge is all the way down here. So Bobby can't just travel this distance. He has to walk down, over, and up. So if we say the down is like 2 miles, and the over is like 5, and then the up is another 2 miles. then total distance, how far did Bobby travel?
9 miles.
Yes, 9 miles. Okay, so his distance would be 9 miles. But his displacement is just the shortest distance from where he started to where he ended. So this distance here, which we know is 5 miles, would be his displacement. Okay. So you can see how they are different from each other. If you travel in a big loop and you end up back where you started, your displacement is 0 because it's the distance from where you started to where you ended, and they are the same location. So you have a displacement of 0. Okay? If you travel, let's say, up and to the left, then your displacement is the hypotenuse of that triangle that you just made, because it's the shortest distance from where you started to where you ended. Okay? So hopefully now you can answer the last objective of the day, which is distance versus displacement. Okay? This is the end of the notes. Your homework for today should have posted on Google Classroom. It's called 1.1 Check for Understanding. It's like 7 questions long. It's a Google form, so you can, some of them are multiple choice, some of them are fill in the blank, some of them are short answer. I would really like for you to take advantage of the fact that you're having class time to do this. So I don't want to see people who haven't finished their homework doing something else, because you have time in class now so that I can help you if you get stuck. If you do something else now and you go home and try to do this later and you get stuck, I will not be there to help you. Okay? All right.